All right, problem 4. Here they want me to show that this triangle must be congruent to this triangle. Okay? And we're going to start like we've been starting all of these by putting the given information into the diagram. And fortunately for us, this is kind of done already. We've got this which says that WV is parallel. And that's what these arrows are. They indicate parallelism. Parallelism does not mean congruent. It's not the same as congruent. All right? It doesn't mean that. Okay? So you need to get that out of your head. It tells you something else. That's why this problem also tells you, hey, you know those sides we just talked about? Look, I'm going to promise you that they're congruent. All right? That's a side fact. All right? That's a side fact. But when they tell you things are parallel, like when they give you parallel lines, here is what they do. 9 times out of 10, basically all the time, they're going to make alternate interior angles. They're going to make this Z shape. Right? The two parallel lines at the top will be connected by a transversal, and in the corners or the armpits of that Z will be your congruent angles. And we'll have that here too. So I guess I'll do that with I'll do that with a red. That will show up nice. So here is that parallel line at the top. Here is that parallel line at the bottom, right? Boom and boom. And when we connect them with that transversal here, when we connect them in the corner, they're going to make an angle from that green to the red, from that red to the green. They're going to make an angle. And I know these angles must be congruent because they're alternate interior angles. I guess I'll write that out for you. Alternate interior angles. And this angle here is YXV. That is angle YXV. And then the other angle, the angle down here, this angle here, that is WVX. That is angle WVX. That vertex where the angle is has to go in the middle. Where the angle is has to go in the middle. So that's a nice way to remember it. Okay. Well, let's go ahead. So now we've got an angle fact, and now we need one more fact, either a side or an angle. And I see when I go to my free facts, I don't have vertical angles, but I do have the reflexive property. I get that reflexive property at XV that cuts down the middle of both of my triangles. So right here, this piece, right, XV, that's going to be reflexive. And that's my third fact. That's side angle side. That's how I'll prove this. So I'm ready to write up my proof now. And I'll start with the givens. I'll start with WV is parallel to XY. How do I know that? Well, that's given. And I guess I won't break. I'll follow my own rule. WV is congruent to XY. How do I know that? Well, that's given. And that is a side fact because it has that congruent symbol. This is not a congruent symbol. It doesn't count. This fact will tell us something. It will tell us a third fact, that this angle here is congruent to this angle there. So angle YXV must be congruent to angle WVX. How did I know that? Well, that's alternate interior angles. And because I said, hey, I've got parallel lines, that's what allows me to cite that as a reason. That's why I needed to say, hey, we got parallel lines first. And that's an angle fact. So I'm going to keep on going. I'm going to take a look at my diagram and I'm see, oh, this is that reflexive thing, right? X marks the spot. So XV is the same as XV itself. And my reason for saying that is, well, that's the reflexive property. And that's my third fact. And I can see I have side, angle, side, and now I'm ready to write my final statement, namely that these triangles, triangle W, X, and V, must be congruent to triangle YVX. And I'm just copying that over. I'm looking over there. And I can see that's a side angle side. So SAS. Give it some sass.